Okay, in this example we're going to use nodal analysis to write a set of equations to find V0, the voltage across this 2 kilo ohm resistor with that polarity. Now the first thing I need to do is define independent and dependent nodes and choose a reference node. I think I will choose this as my reference node, 0 volts. The choice is arbitrary. Now to find my dependent and independent nodes, I'm going to kill my sources and redraw the circuit. Okay, so the voltage source becomes a short circuit, making this all one big node, which tells me that this node and this node are not independent. They are dependent on one another. This is my 0 volts, so this is my other independent node. I think I'll arbitrarily choose this as one of my independent nodes. This is going to be my other one. Then I need to label the voltage at this dependent node. This voltage down here is going to be 6 volts below the voltage up here with this polarity. This is my plus, this is my minus, so this voltage here is VA minus 6 volts. Now I'll do KCL at A, and it's easiest to define A as this big supernode, because really there's only one unknown voltage here, VA. This voltage down here is known to be VA minus 6. So summing the currents leaving that node, this direction, and this direction, so VA minus VB over 2 kilo ohms is this current here. This current is going to be VA minus 6 minus VB over 2 kilo ohms. So this current's going in this direction. I treat this as the positive voltage and this is the negative voltage. Plus this current here, which is going to be VA minus 6 volts minus 0 volts over 2 kilo ohms. That sums to 0. Now let's do KCL at B. So redefining my current directions as being positive, leaving node B, I get this voltage polarity, this voltage polarity, and this voltage polarity that I have to use. So KCL at B is VB minus VA over 2 kilo ohms plus VB minus VA minus 6 volts over 2 kilo ohms, which is the current in this direction over here, plus VB minus 0 volts over 4 kilo ohms. That sums to 0. So this is 2 equations and 2 unknowns. I can solve those for VA and VB, and then I can find V0 in terms of VA and VB. V0 is the difference between 0 volts and VA minus 6, with the 0 volt side being assumed to be the higher. So V0 is equal to 0 volts minus VA minus 6 volts, which is just equal to 6 volts minus VA. Now I have 3 equations and 3 unknowns that I can solve for V0.